More complicated scatter profiles, in particular those that differ significantly as a function of angle of incidence, need a more complicated structure for the BSDF fit. Within ASAP, we're going to use a polynomial fit. The polynomial fit allows you to define a polynomial of n by n terms. Generally, you'd want to start with, for instance, an n by n of 2, and this will give you about 18 terms that can be applied to the fit. What we'll do now is load in some data. What we have is scatter measurement taken at a 5-degree angle of incidence, as well as some data taken at an 80-degree angle of incidence. And let's put these two curves on the same plot. And what we'll need to do is apply a fit to both of these curves. Now, in the Harvey model, we had a limited number of parameters. The polynomial model will allow us several more. In the case of this utility, we want a maximum of 10 variables at a time. Since I have 18, I'm going to turn off the last 8 and then perform an auto fit. And as you can see, I still need to continue to fit. I'm going to add some more terms, and you'll notice that if I iteratively press the button, it's going to get a better and better fit to those terms. And as you can see right now, it's pretty good, except we need a little bit of work up here. So now what we'll do is add a few more terms and selectively turn terms off up here. And this is an iterative process. We'll go through a few times and do a fit. And as you can see at this point in time, considering that scatter measurements within even 10% are considered reasonable, I would probably be quite happy with this fit at this point in time. I could, of course, continue to iterate through to try to maybe get a closer fit at the 80-degree angle of incidence. And again, you do that simply by locking and unlocking terms and then letting ASAP apply its auto-fit routine. But assuming I'm happy with the data, what I want to do is to create a profile of this information, a scatter model in ASAP, that I can use in my design work or my analysis. So what I'm going to do is open up a new INR file, go back to my utility, and then I have a copy option on my button bar here. So I'm just going to select copy, go back to my INR file, and I'm just going to paste that data there. And this is the polynomial fit defined as an ASAP scatter model. It's telling ASAP that it's a 2x2 polynomial. What I can also do is tell ASAP to plot this data. And what this will do is give me some views of what this scatter model looks like, not only at our selected angle of incidence, but at several angles in between. And I can simply run this file, and all we'll do is look at what the polynomial fit of the scatter data looks like. And what we have is the log BSDF plotted against the log of beta minus beta naught, the sine of the angle minus the sine of the incident angle. And here's the log BSDF as a function of the angle of incidence, both forward and back scatter directions. And this data is very similar to what we had in our initial curves, so I'm happy with this results, and I would then be able to apply this model to any ASAP surface. The other thing I can do is, if I go back to my BSDF Fit Utility, if I try to close the utility, it will ask me if it wants me to save changes in the Fit Utility. And if I click yes, then what I can do is say I have my polynomial of my black material, or whatever the appropriate name is, and I can save that. And in the future, I can load that file in at any time and copy and paste the actual parametric data.